Recorded is rolling. It is Friday, March 20, day before spring break. So I want to go a little slower, wind down a bit. Yesterday, you guys did a in-class, or you guys did a team quiz, and somebody turned that in. And then you can turn it today if you need to take that home and take a bit more on some of the questions. Make sure that whatever we've done so far in quarter four, which is just the assignment you have turned in, so you're not going into spring break with anything missing. Right. Guys, before I hit all this other stuff, here, we're going to do one of three things today. I'm going to have you guys vote. So I'm going to give you guys this option so you have at least a minute to think about them. All right, so one option is, in my other classes, we're doing some optics. So I could give you guys these prisms and some lasers and have you guys, and some protractors, have you guys measure refraction angles and give you guys a crash course on reflection, refraction, and Snell's law. But last class, that got one vote. Option B is I could give you guys the template to make this Newton's wheel on one side and a Newton's wheel on the other side. That works super well with the camera frame rate. Yeah, a little bit. Works pretty good person. All right, and talk about color theory. That got one vote last class. Or there should be some cards scattered around. We could do game theory and play something called the prisoner's dilemma. That got 9 votes last class. So you guys be thinking on that. What you want to do? Right. Then mentioned too. Yesterday, so some of you guys at International Fair, you guys did some pretty good performances. That was pretty fun. All right. So of course we're going into spring break. I'm not officially assigning anything because we all need a break for sure. But if you wanted to study something, you have lots of options. So at least I can throw these out here. I've had you guys keep lots of notes over the last few weeks. Or for the whole year, for that matter. That PowerPoint we did go through for review, I uploaded March 9. You guys can download that and go through that. There are safety classroom videos. If you Google this called Flipping Physics, this guy has a channel. It's a pretty good review. When we get back, we're going to pick up where we left off. So that'll be energy conservation, energy, work power. Okay. All right, any questions about what's going on? All right, so over here, you guys ready to vote? Okay, guys, we're going to do one of 3 activities today. Take us to the spring break. We can either do reflection, refraction, Snell's law, and break out the lasers. I'll give you guys some lasers and some prisms. We can build this right here, Newton's wheel and Benham's wheel. Or you guys can learn about game theory, and we're going to play prisoner's dilemma. All right, so everybody got something in mind they want to do? Yeah. Show hands. Who wants to do lasers? All right, Mafia Rise. Oh, 0. Who wants to do Newton's wheel, Benham's wheel? Oh. Who wants to do prisoner's dilemma? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Well, 0 to 0 to 12. I think it's unanimous. Yeah. That's a prisoner's dilemma, which is a specific scenario within game theory. So first I gotta tell you guys a little bit about game theory. Here, so I got Wikipedia pulled up. Show you guys. Hold on. What just happened here? Hold on. My browser's doing something weird. Okay, let's just kill that. All right, here we go. Game theory. And so this is a subset within economics. This is the study of mathematical models of strategic interactions. Oftentimes you have 2 players. Guys, look up here so you know what's going on. Everybody got paper too? I'm going to have you guys write something on paper. And so usually there's a player A and a player B. If you want to get more complex, you could have multiple players. Also, you could have one iteration or multiple iterations, and you could choose different games with different points and different strategies. Right? Now, guys, how about here? Guys, look up here. I'm trying to show you something cool. Here, come, sit down. Everybody look up here. And so game theory was developed extensively in the 1950s. Guys, why do you think, guys, sit down, look up here. I'm trying to show you something cool. Why do you think the U.S. government was pouring billions of dollars into studying game theory in the 1950s? Guys, what was going on in the 1950s that we weren't?
War. The Red Scare.
Yeah, okay, there you go. Like Cold War, right? Cold War, right? So, guys, about 1950s, this was the first time in history that 2 superpowers had nuclear weapons and intercontinental ballistic missiles where you can very quickly completely annihilate another society. So questions started to arise. If one of these superpowers throws a missile at the other, what would the expected response be? What would it be for different scenarios? What about 3 missiles? What about 100 missiles? And regardless of the particular scenario, Do you guys remember the general outcome? What was the what was the outcome they decided would probably happen? Mutually assured destruction. Yeah, MAD, MAD, mutually assured destruction. The idea is that it probably wouldn't end with a simple tit for tat of one for one. I mean, maybe, but if you can't count on that, then while there's a set of missiles going through the air, you have a few minutes to respond and try to blow up the other side's missile silos as many as you can. Now all the missiles are flying, right? So yeah, it's led to a state of nuclear deterrence, right? So last time nuclear weapons were used was World War II, and then of course there was only one country that had them, which was the United States, right? Right, but what if there's more than one country that has nuclear weapons? So there's been this deterrence, right? Right, so there's a lot more on this, but here show you guys. So within game theory, there's a particular set of scenarios where mathematically, well, here let's look at this one.
Let's say Mr. Blue and Miss Red have each been arrested for some minor crime. The police think they committed a more serious crime, but they don't have enough evidence to convict them. They need a confession. They take them and put them in separate rooms so they can't talk, and play a little game. To try to force a confession, the police give them each a choice. Admit your partner committed the crime and you will go free. We'll pardon you for the minor crime, but your partner will have to spend 3 years in prison. If you stay silent and your partner lets us know that you were the one who really did it, then you're gonna have to go away for 3 years. They know that the police don't have any evidence, and if they both stay silent, then they will only go to prison 1 year each for the minor crime. If they both betray each other, then they'll both go to prison for 2 years each. Okay, each partner can do one of two things: stay silent or betray. Staying silent would be cooperating, and betraying would be defecting. If they both stay silent, then they each spend a year in prison. If one betrays and the other stays silent, then the betrayer goes free and the silent spends 3 years in prison. If they both betray, then it's 2 years each.
All right, so that was really fast. So I'm gonna pause here. Let's digest this. Now, cooperate means cooperate with your partner, so you're not talking to the police. Defect means you're selling out your partner, trying to get a better advantage to yourself. Okay. So, if you each don't talk to the police, maybe the police can find some minor charge they can get to, but it's not very much, just a year each, right? And for the whole group here, well, for the team of two, wouldn't that be collectively 2 years? Okay. Now, if they sell each other out, then you work in this quadrant down here, so now you each get 2 years, right? Which for the whole group would be 4, right? And then if one defects and the other doesn't, then be either 0 to 3 or 3 to 0. If you defect, then you can walk away completely free, but your partner gets 3 years, which would be the worst outcome. Would be 3 years individually, wouldn't it? Right? And then for the group, collectively, it's 3 years. Right? So look at it from the group's point of view, because I'm saying if someone was better for the group, if they could somehow come up with a strategy and they stuck to the strategy, what would the best strategy be for the entire group?
Cooperate.
Yeah, cooperate, because that's collectively 2 years in prison, which is the least number for the entire group, right? Okay. And that would be called the socially optimal outcome. Socially optimal, as in, well, within the if all that matters is the university's 2 people, right? So for their group, that would be optimal. Okay. Now, if you look at their individual incentives, though, because now that they're split up and they don't know what their partner's doing, if you look really close, regardless of whether their partner defects or not, cooperates or defects, it's still in your individual interest to sell them out. So let's see why. Right? So suppose your partner is actually cooperating with you and doesn't talk to the police. If you also don't talk to the police, you go to prison. But if you sell out your partner, I'm saying if you're the red person here, oh look, you go from 1 year to 0 years. You get to walk away. So you're better off selling your partner. Or what if instead your partner is blabbing over here, selling you out, saying, you did the whole thing. If you are trying to cooperate with your partner and you don't talk, but your partner does, now you get the worst possible outcome for you individually, which is 3 years in prison. But if you had gone ahead and also defected, so now your partners are selling each other out, now you go from 3 down to 2. Oh, so you as an individual, no matter what, you're always incentivized to sell your partner out. Is that? And this bottom right quadrant, this is called the Nash equilibrium. The Nash equilibrium, what you can expect. Right? So do you cooperate with your partner or not? Right, now, here, I'm going to zoom ahead and give you guys one realistic scenario. The nuclear deterrence and mutually assured destruction can be considered an example of this. Right? But let's talk about cigarettes, since that's the example here, cigarette advertising. Guys, have you ever seen a cigarette ad on TV?
No.
No. Or what about a billboard? Have you ever seen a billboard cigarettes? No. Because those have been banned for many, many decades, like before I was born in the States, right? Now, why? You might say, okay, well, maybe from the point of view of public health, government wants to disincentivize smoking since it's bad for health, right? That might be an incentive for that law, maybe, right? But you guys know a lot of laws that are enacted, there's a lot more behind the scenes like lobbying and interest groups and yada yada, right? You can make the case that from the cigarette company's point of view, it's actually in their benefit for the government to ban their own advertising. And here's why. You're looking at the quadrants why. Right, so up here in the top left is let's say here's the scenario, just simplify. Let's go back many decades ago to like 1950s where like almost everybody smoked. So if nobody advertises at all, the blue company, the red company, nobody's advertising, then people are just going to buy random packs of cigarettes and they'll say they split the market 50-50. They each sell like half the cigarettes in the market, right? Now, if one company decides to advertise, do you think more of the customer base is going to buy their cigarettes instead? Yeah. But in this case, you're not really producing more smokers. You're not convincing people to smoke that weren't going to smoke anyway. What you are doing is you're stealing market share from the other company. So that's like here, maybe the blue company decides to advertise and the red doesn't. Now, advertising costs money. Maybe it costs millions of dollars to run these ad campaigns. So that's a little bit of a loss, but you get more market share, which overall is a benefit to your company at the expense of the other company. And then here's the vice versa. What if the red advertises but the blue doesn't? Now, if they both decide to advertise, that brings you down to this Nash equilibrium in the bottom right, where now the market share is back to 50-50%. But there's a huge loss in advertising dollars. So they've lost a lot of money along the way because of advertising. You guys see that? Right, so this is another prisoner's dilemma. Right, now we're going to do some prisoner's dilemmas. You guys write your name on your paper. Call this prisoner's dilemma. Prisoner's dilemma. And we're going to do a few scenarios. See how much time. Yeah, okay. We're going to do a few scenarios. And so I'm going to draw some quadrants.
We turned it into third grade.
I'll give you guys some points. Yeah. You guys points with us. Okay. And you guys copy the quadrants I'm drawing. And try to make these squares about the similar size on the paper. Because I'm gonna write some stuff in the margins. Alright, get some squares going. These are gonna be individual games, and we're gonna change the rules of the game as we go along, and maybe that'll set up different incentive structures, or you guys get a feel for this, and maybe come up with some strategies. Okay, so quadrants, just like you saw for either selling out your partner not to potentially go to prison or so many prison years, right? Or what you saw with the cigarettes or cigarette companies trying to figure out should they advertise or not. Okay. Both of them had quadrants that look kind of like these. Quadrants here.
We used to smoke cigarettes. As a teen. What? I'm not getting done right now. But see, juice, man.
All right. All right. So we got 4 games set up. All right, let you guys catch up to there. All right, you guys are getting all these games set up.
Bro,
Games set up. All right, you guys getting there, getting there.
they're down my county a full time. I think that's relatively close.
Getting some games. Getting some games.
I run somebody.
Okay.
Yes. I challenge.
Hey, you should have some cards within reach. So I'll tell you what the cards mean in a minute. But there's going to be your partner can choose one of 2 options, and you can choose one of 2 options. Partner and you. Right. Guys, you should have a black card within reach and a red card. You guys each have a black card and a red card within reach. Okay. And if you don't, then I've got a few extra cards that I'll throw. So you can either choose red, black, red, black, black, red, black, red. There you go. To throw a red or a black card. Right, let's catch up to there. Alright, so it's you versus partner. And each of you has a one black card and one red card.
Partners and friends.
I hope officer you down on the phone. You down? Officer.
Okay, you guys getting pretty close to what I have here. And so here's what the cards mean. A black card is going to mean cooperate. Cooperate. Okay. That's to say cooperate with your partner. If you throw a red card, that's going to represent competition. Competition against your partner. So black is cooperate with partner. And red is compete against your partner. Okay, so it's you versus your partner, and then I got red, black, black, red.
Alright, can we make our decision?
Well, hold on, we're getting close.
My card said like.
You guys finish right to that. Okay, you guys up to here.
No.
Alright, so here's how it's gonna go. Okay, so you know your own cards. Guys, you're allowed to choose whether you're gonna cooperate with your partner, which would be black, or compete against them and try to get a better deal for yourself, which would be red. Okay. Pick one. Let's say I say, I'm gonna choose this one. Okay. I put this face down. Now, I know what card I picked, but my partner does not know. My partner's also gonna choose either red or black and put that in the middle of the table. Now we got both cards in the middle of the table. We each know what we picked individually, but not for the whole group yet. You guys get that? Okay. Then we flip over the cards at the same time. Suppose it was this outcome, where I chose black and my partner chose red. Well, there's no particular outcome. We got to assign some points to this. So let's come up with a points system. All right, let's go here. We're going to start with this point system. Now, in this game, let's say points are good. Don't worry about years in prison or anything like that. Okay, so you want as many points as you can get. You guys get that? Want as many points. So in this game, let's do red and red is going to be 1 point each. Black and black at the bottom here would be 3 points each, which is better. Okay. But 3 points is not the most you can get. The most you can get is if you throw red, that's like selling out your partner, competition against your partner. Your partner throws black. So in that case, you could get 5 and your partner gets nothing. But the tables could be turned. If you throw black and your partner throws red, you get nothing and your partner gets 5. Okay, so let me write down that score matrix over here. Okay, so if you each throw black, you're working with each other. It's 3 and 3. If you each throw red, you're competing against each other. It's 1 and 1. Okay. And if you throw red, your partner goes black. You get 5 and your partner gets nothing. But if you threw black and your partner threw red, well, now the reverse. You get nothing, your partner gets 5. Okay. So it's you versus your partner. Okay. So you guys get that? Okay. Now another aspect of this is how many iterations do you do? Do you do 1 iteration, 100 iterations? We're gonna do 5. So we're gonna do iteration 1, 2, 3, 4, 5. You versus your partner. Then add up your score. So I'll say summation. Okay. And we're gonna find a winner in this class. We're gonna see who's best at this game in this whole class. Somebody in this class is gonna have more points than anybody else. Okay? Okay. So I'm gonna pause this recording. Give you guys a minute or two to, with your partner, play this game, do 5 iterations, and add up your score. Hey, we're back recording. So I need to find out who got the most point here. Let me give you guys an example. For example, what if I chose black, my partner, black, I got 3. And I did black, my partner did red, so I get nothing. And then let's say we do that again. Right, and then maybe I choose red, my partner goes black. And let's say we do black and black. Okay. So you have 5, 6, 7, 8, 9, 10, 11. Okay, no, I just made that up, but you guys get that. I would have 11 points. Okay. So guys, show of hands. How many of you guys got at least 11? You got at least 11. Ooh, quite a few guys. Did you get 15?
That's how you win, but
Oh, let's go 12. 12.
I got 13.
You got 13? You got 12? 13?
I got 15.
Wait, who got 15? All right. All right, Luke gets 15. Oh yeah. Alright, so Luke wins round one. Wins round one. Alright, let's play a new game. New game. Well, all we're gonna do is change the incentive structure.
Oh.
And so red and red is still 1 and 1, black and black is still 3 and 3. Right. But now, red versus black is 7 versus -1, or vice versa, -1 and 7. Alright. So here. Okay. Okay. Guys, I'm pointing to you right now. Black and black is 3 and 3. Red and red is 1 and 1. Same as before. The only thing changed are these quadrants. So red versus black, the red gets 7, the black loses a point. Or vice versa. If you play black and your partner plays red, you lose a point and your partner gets 7.
Are we doing which partners?
Yeah, you can get if you want. Right. Yeah, so same as before. Do 1, 2, 3, 4, 5. Okay. Then add up all the points. We gotta find who wins this game. Who's best at this game. Alright, back recording. So who got at least 15? 15. Maybe at least 20. 25?
Wait, I got.
We count the one.
Oh, you still have what?
No.
Right, how many did you get?
35.
You got 35? Oh,
Are we adding on to a previous
no,
one?
it's a whole new game. It's a whole new game.
How did you get that many? Yeah, well, why would someone like?
Alright, Luke, 35. 35.
No, but I think.
Alright, let's try a different incentive structure. Okay, here's a new game. Alright, so now red and red is 0, 0. Black and black is 6 and 6. And then let's keep the next set same as it was last time. We'll have the -1, -1 to 7. Okay. So switch over, show you guys how I. Alright, so here's how I copy those numbers in. So black is 6, 6, red is 0, 0. Okay, and then red versus black is same as it was last time. Alright, so same as before. Pause this video recording. Let you guys play that version. Alright, we're back. Alright, so who got at least 25? Who got at least 25? Who got at least 30? 35? How much you get?
35.
Oh, you got 35?
You did not get 35.
Yeah,
Yes, you got 35.
No, I did it. I got
This round we got 30.
I did it with the Ivy player.
Okay. Alright guys, move along here. So, have you guys ever heard the phrase zero sum game? You guys ever heard that phrase?
Yeah.
What do you think that means in the context? Guys, if something's zero sum, what do you think that means mathematically?
It adds to 0.
Yeah, if you add up all the numbers on the table, guess what they add up to?
0.
0, right? See, like there could be some negative numbers and so on. Right? No, in this case, would these be zero sum games? No, because there's some positive value. So as long as you keep playing this game, overall the number of points keeps increasing. But if somehow the sum of the values was 0, then somebody loses every time somebody wins as much. Right? That would be an example of a zero sum game. Okay? How about this? Right. Suppose you have computers playing against each other. Here, you got a computer here set up. You got a computer here set up. Okay. And you load them with some algorithm, and maybe they're playing over the internet, and they do maybe 5 iterations or 500 iterations or however many. Okay. And each algorithm, by having some strategy, and then playing against lots of other computers with their own strategies. At the end of maybe these hundreds of games with hundreds of other computers, there's going to be some strategy that's going to end up getting the most points on average. Okay? And there's different strategies. Like you can always play black, or you can always play red, or you could switch back and forth. You could be random, right? Now, guys, the strategy that tends to win more often than any other strategy is a very simple strategy with just 2 rules. Do you guys know what that strategy would be?
Always bet on black.
It's called tit for tat. Okay. And the 2 rules are this. Rule number 1 is that the very first card you throw is always black. You always cooperate in the very first round. Okay. And if whoever you're playing against always cooperates with you, then you just go into a cooperation loop. Okay. The second rule is that if whoever you're playing against throws red, you throw red the next turn. And you always play what they played the previous turn, so that they have to learn to cooperate with you. All right, so that's usually the winning strategy. All right, we'll do one more round here. Last round. Who wants to come up with some numbers? Who wants to volunteer some numbers?
67.
All right, Richard. What
67.
we're doing? 67, 67. What about red and red?
67, 67. 420.
Well, it's got to be smaller.
41.
41, 41. All right, how about red versus black? What's gonna be? 10,000. And what?
And
40. 10,000. All right, guys. Let's set. Do 1, 2, 3, 4, 5. We got one more winner. We got one more winner.
I don't think about it like that. I said 5 blacks.
All right, we're back. Who thinks they might have the most points? What would you get?
50,000.
You got 50,000. All right, 50,000. All right, you guys, turn the paper in the great trade, and I'll give you guys points for that. And you guys have a good spring break.